For 11 methods, we're going to look at question 11 from exercise 2H. A helicopter is hired for $210 per day plus a distance charge of 100, no 100, $1.60 per kilometer. Alternatively, at a fixed charge of 330 per day for unlimited distance. For each of the following methods of hiring, find an expression for the cost C in terms of the distance traveled X. So already we know that C is like our Y and X is obviously just our X. So what if I find an equation for both of them? So for part A, I know that C is my Y. We've got to find our gradient. Our gradient must be 1.6 because that's what the rate is. Because we're getting charged 1.6 per kilometer traveled. So 1.6 X, and we're going to get a fixed charge of 210. So that's going to be 1.66 plus 210. For the second one, for the second equation, it says at a fixed charge of 330 per day, regardless of distance. Okay, so how would I write that? It's like a flat rate. Okay, so I'm getting charged. The gradient would actually be zero because I'm not getting charged on, on a rate per distance. I'm getting charged 330 per day. So your equation is just going to be a flat line. Okay, so on a set of axes, if you were to draw that, they'll just be literally be a flat line. Okay, like that, with gradient zero. Okay. For B, on the same set of axes, draw the graph of costs versus distance traveled for each of the methods. Okay, so we'll on one set of axes, meaning on the same set of axes, we want to draw the same. We want to draw the both the things on the same set of axes. So I'm going to draw one graph, and you're going to use a ruler for this. We've got cost here, and we've got distance traveled there. Now, I already know that my this graph here is going to be a flat line. It's going to be 330. It's going to change. My second graph, we're going to have a y-intercept or a z-intercept of 210. So 210 somewhere roughly around here. And we know it's increasing. So it's going to increase and we're going to have an intersection point. So we've got to find that point of intersection. Then we would have drawn our graph. Okay. So how do I find the point of intersection? Now I can use the substitution because C equals 1.6x plus 210. I can sub this value in for C. Okay, so 330 equals 1.66 plus 210. So if I subtract 210 from it, I get 120. 120 equals 1.66. So going to use a CAS calculator to get our exact value. So we've got, or you can do it at the very start. So 120 divided by 1.6. 75. Okay, so x equals 75. Okay, and I need to figure out. Okay, so we know it's going to intersect at 3075. 330. Now, how did I know that my C quantity is going to be 330? Because this is a flat line, so it has to be 330 over there. Okay, so I didn't even need a calculator to work that out. Okay, so and I finished my graph. So I've got my C intercepts and my my point of intersection, so that works. So part C, determine what for what distances the fixed charge method is cheaper. So this is a thinking question. Where is it cheaper on the graph? So we know that for the fixed charge method, we're looking at this method here, the blue line. Where's the blue line? When's the blue line more affordable? It's more affordable right here because if you go beyond 75 calls, or well, sorry, not 75 calls, 75 kilometers, you can see that the other rate will be much more expensive because you're going, it's increasing above the $330 rate. Okay, so it'll be after 75 kilometers. will be cheaper. At 75 kilometers, it'll be the same price, but have to be after 75 kilometers. So hopefully that gives you an idea how to do this. And again, if you want to solve this simultaneously, you can do it. So you got y equals 330 and y equals 210 plus 1.66. And solving for x and y. And you obviously get the same answer. So hopefully that helps.